Hi, everyone. How are you doing? Still awake, still ready, or waiting for lunch? So let's take a small trip from the data lake to the modern service mesh. And clearly, we're going to use all OSS. So let me just introduce myself. I'm Luca. Nobody can pronounce my surname. It's Maraschi, but call me Luca, it's fine. And I'm Chief Architect at Telus Digital. As you can hear from my accent, I'm Italian, but I do live in Canada right now. So I'm here to take you on a journey, and I think our previous talk was a perfect transition to intro to our journey, right? Because as an Italian, I definitely love food. And so I'm going to use food as much as I can to drive you to this journey. And does anybody know this dish? So this one is one of the most iconic dish that we have, basically from the most famous Italian chef in the world, Massimo Bottura. And it's his signature dessert called Oops, I Dropped the Lemon Tart. And I think it's actually pretty interesting because the whole journey that we made, there is a squeaky floor, is actually pretty similar to the experience that inspired this dish. So let's take a little bit of a history lesson, right? We all know where we all started, with a big monolith. And through the years, we moved to microservices. And most recently, we moved and shifted our focus on functions, and if you want to call them also serverless, this kind of world, where we kind of shifted the responsibility of executing code in the bare minimum and simple, almost atomic particle, right? A function. And in this journey, what happened with data, right? Because those services, they need somehow to provide data to consumers. Because what we are building on a day-to-day job, most of us, is to build APIs as services that are going to be consumed by applications and or third-party consumers. So, and data went through a very interesting phase because we went from moving data from a source of records to centralized aggregated sources through ETL processes, so extract, transform, and load. And we call it the ETL pipe. That's why there is a pipe. During the time of microservices, we experimented with more streaming architectures, right? So where Kafka, for example, was a dominant player. And once again, most recently, if we come closer to 2020, the journey took us to what is the reactive model, right? Or mostly common in architecture, the actor pattern. Is anybody familiar with actor and actor systems? Great, because that's actually at the core of distributed systems, right? That's how modern distributed systems, they operate. And the interesting part of this model, which is kind of relevant for our story, is that we actually always had to fight with resiliency, consistency, latency, and especially we need to keep these services up and running all the time, reducing cost. But yeah, like always, there is a problem. We shift the data moves, but is always a little bit too far from where it should be, close to the user, right? And that's why we experience this incredible growth of latency the further we get from the client to the data source. And this one makes very, very unhappy our users, right? Because at the end of the day, we are building those systems. And I think now, you know, we kind of solved partially the problem for delivering assets and delivering static pages. But web services, they are still a very interesting challenge, right? We evolve in the world of CDNs and in content delivery networks. But still, you know, if you have an authenticated user, what are you going to do? You cannot put his data or our data on a CDN. So, and clearly the eternal problem is always the one on how to coordinate and keep, once again, up and running and resilient the old system. And at the same time, how can we move forward? And I think, how many of you are familiar with what 5G is? Because I might be, okay, so working for a telco company is something that I'm hearing every day long, so, 5G is not just the evolution of 4G, right? Is the evolution of how we think about delivering really data closer to the consumer devices, right? We are not looking at the user itself, but we are thinking about the device, right? So that's why there is this tremendous growth of edge computing, right? So if you look at Azure, for example, AWS, Cloudflare, they all try to push into edge computing. And 5G represents actually the evolution from an infrastructure perspective and a distribution perspective on how we can basically push data outside of the data centers, where clearly they mostly reside, and go closer to the consumer devices. And so this one will create high speed, high throughput, high resiliency, high distribution, geolocality, and all these kind of fancy words. But at the end of the day, we still live in 2020. 5G is not everywhere. This one is just a dream. So we need to take a step back into reality. And not so long ago, we were kind of challenged with this problem, right? How can we develop a system that is resilient and reduces the time for our consumers and our users to get their data on their phone, on their website, anywhere? And we actually had to take a look of the current kind of ecosystem, right? We just said, so a user could use it, connects through a UI or a device through an API, which consumes a model, which somehow is in a database. It's actually kind of interesting. You could actually try to use Google Spreadsheet to be a little bit faster, but it was not recommended. One of the things that we considered, we said, well, there must be a better way, right, to how to solve this problem. And if you, oh, sorry, I pressed the wrong button. If you take a step back into this picture, you see that there is a lot of traffic going on through that API and also through that database, right? There's a sort of bottleneck. And we said, well, there must be a way to solve that bottleneck in a way that can scale massively without having to reinvent the wheel. And so, the green button doesn't like me. We actually kind of look into a very commonly used pattern in, I love to mention banking, but it's mostly in distributed computing, that is CQRS. How many of you have ever played or know what CQRS is? They had a very bad experience with CQRS. Well, CQRS is a very fancy name, which I never remember what it really means, but it's basically a responsibility segregation, right? And if you were to put on a diagram what the CQRS pattern really means, it means to separate read and write operations. And one thing that we kind of assume is that the real problem, the real throughput problem is always on read operations. And then we said, okay, well, we can kind of forget about the write because the write will always need to be strongly consistent. But we can live with the fact that I'm going to read some data from somewhere, and this data might not be strongly consistent, might be eventually consistent. Also because if we were trying to solve this problem in a strongly consistent way, we would solve the eternal issue of the cap theorem, right? Which we all know we cannot solve the three variables of cap all in once. And well, after some kind of interesting whiteboarding exercise, we said, well, let's imagine that we are living in a stream environment, right, where data flows from the data warehouse or the source of record up to the consumer, right? And you know, we actually kind of thought about this problem. We said, well, to transfer data from whatever source of record that is distributed up to where the consumer can use it is going to take a lot of hours. And that's too eventual to be consistent for a user. So there must be always a better way. And so we said, if we just take a lagged approach and we try to apply some concept of CDNs to our data set, we can achieve almost the same kind of level of distribution, consistency, and at the same time, speed to the user, so lower latency. So just to walk briefly on this diagram. Can you guys see the diagram and what's written inside? So in a nutshell, is the flow that goes from source of record to a broker, Kafka. Please don't call it a queue. With a bunch of a battery of workers that are orchestrated by Argo or Brigade. And they go somewhere in an ephemeral state, and they're consumed by a battery of GraphQL services. So like I said, every good Italian dish has a recipe with very simple ingredients, and they say that the magic is in the chef. I would say that there's no magic in the chef, there's just the correct order on how to put the ingredients and the quantity. So if you were to take a note of this recipe, I would actually note down Argo and Brigade are a very, very interesting Kubernetes-based workflow orchestrator that really can work extremely well to solve this kind of worker problems. And the other one is definitely GraphQL. So, well, we had a diagram. Everything always works on paper. I can tell you that you don't even need unit tests on paper. But yeah, we had to start stitching these solutions together, right? And like I said, one of our main ingredients is that, like, when you cook something, you want to use organic ingredients. We decided to go for OSS ingredients, right? And we started our base for this pasta sauce with Fastify. How many of you are familiar with Fastify, except for the people who wrote it? Okay, that should be all here. Okay, super. Okay, Fastify is a no-brainer, right? So why did we go for Fastify? Most likely because the plugin models and the separation of concern that is a first-class citizen of the framework. And if you want an example of this separation of concern, plugin model, and scaffolding, Fastify CLI is definitely a great example, right? A couple of glitches here and there that once that you define your structure, it becomes very difficult to inject your customization or so on. But yeah, that's why you want to template, right? You want to have a uniform and consistent way to distribute the application across your developers. And in our picture, we had Kafka. And in my career, I have been asked several times, and thanks to Matteo Collina, I became the Kafka man. I've been asked several times to, what shall I use to connect to Kafka? And that was the same question that people in my team asked. And I said, well, there is a very nice library called Kafka Node that doesn't require a lot of fantasy to know what it does. It's a node library for Kafka. It supports Kafka streams, so from 0.9 up, and is phenomenally fast. So it's extremely fast, and it fits perfectly the picture of having consumer-producer, fantastic. Suggestion for the Fastify team to build a nice plugin for that, because it's a little bit mechanical to implement. But let's go back to our main diagram, because that's where I think it becomes a little bit more interesting. So we look into this infinite flow of data, right? And we have Kafka as a broker to push through some workers all these kind of denormalized data into some sort of normalized data store, right? Because we need to build a mesh. But we said building a data mesh is very complicated, right? Because how can you federate a database, right? You don't want to go back to Cassandra, right? We all know that Cassandra is beautiful, but very heavy to manage. So we said, we need just to rethink on what is data for us, right? For us, it's just a bunch of models that are represented in some sort of graph. And I don't mean the Facebook graph, I mean just like a real database graph. But at the same time, what we need to build, it's a fast way for our applications to consume this data set. And so we took something from the past, like from our tradition. We are going back like 25 years or maybe 35. I was barely born, and Oracle was already pushing, well, Oracle being probably the most outspoken speaker in the world of materialized views. How many of you have ever written a materialized view? Hopefully not many people, so. Why? Because it's a very painful thing, because materialized views, they are not dynamic. They need to continuously regenerate it over and over and over again. So there was not a solution for us. And then we said, well, there must be something better. And I knew that it was close to me, and it was called Elasticsearch. And I said, well, what if we push all the data into Elasticsearch? We know the model at the source. We know that we need to propagate models at the consumer. So Elasticsearch is perfect. I just push data into Elasticsearch. Elasticsearch has a nice functionality to generate a virtual graph out of it. And we can consume it. It's perfect, it's ideal. The other alternative was dgraph, that is at the same level of Cassandra to manage, so that kind of same weight. And we said, well, also Elasticsearch has an extremely fast Fastify client that we can just use to consume data from Elasticsearch, that is Fastify Elasticsearch. So if I had to say, we got our oil, our onions in this tomato sauce. Now we are chopping our tomatoes, all in Marzano, San Marzano tomato. Chop in half, put in your pan. And now we're going to put some salt, that is Fastify Elasticsearch. And, you know, let's look at the updated picture of our dish, right? We have a bunch of entities that are going to then push through a streaming model that is kind of serverless. It's not really serverless because we have a real kind of physical broker in between, and we don't usually release serverless functions. We just use Kubernetes spawn pods into Elasticsearch. And we needed to find an SDK, a sort of interface to consume those APIs without rebuilding custom-made models every single time. And, well, the main problem is that we didn't want to deduplicate the schemas, right? Because then the point of having this graph was completely gone, right? So the difference between having a graph structure and a materialized view structure is mostly on how you traverse these entities, right? So in a materialized, you need always to regenerate new materialized views for a new variation of that model, while in a graph, I just change my traverse. And we knew that we could have achieved something like that if we would combine GraphQL and Elasticsearch. So how many of you have ever heard of this project, GraphQL Compose Elasticsearch? That the name is really bad for putting on slides because it never fits. It's a fantastic project. I really highly recommend to check it out. It's great because it allows to consume Elasticsearch through GraphQL syntax. And basically, our goal was to make the developer experience the best, right? So we're using open source. We are trying to think, how can we make our developers a little bit happier? And now the controversial part of the recipe starts, right? Because I don't put garlic. Other people put garlic in the tomato sauce, and it's Typescript the garlic. It gives me actually the same kind of stomachache sometimes. So why did we decide to use Typescript? Because at the end of the day, we have the same model at the beginning, the same model at the end, and we wanted to find a way to just streamline and automate as much as we could, the all processing and all kind of schema definition. Because at the end of the day, you see it's a multi-leg approach, right? Every distributed pipeline has a multi-leg approach, and every leg requires to regenerate new models, right? Is anybody of you familiar with Thrift? one person. Okay, Thrift is like gRPC, but done many, many years ago. And he's tried basically to unify the way schema-full communication between services, abstracting really the schema implementation. But at the end of the day, you had to write a definition for every single service or client that you wanted to implement. So on that line, we actually went for TypeScript only because of this library. And we decided to use TypeScript only as a pure facilitator for automating schema generations and the developer experience. Once again, I tell to everyone, we did it for the IntelliSense, but it doesn't work in Vim, and I use Vim, so it was not my first pick. Note down this library is great, TypeGraphQL. And with TypeGraphQL, what you do, you basically define like old school ORM kind of like schema definitions, right? And it's all attribute-based. So the trick is to kind of define the type and the query, because we all know that that's GraphQL, right? It's a type, query, and resolver. And the syntax is not really vanilla JavaScript, it's purely TypeScript. But the big advantage of this is that you can basically just compile it. So you can write one schema definition, push this schema definition in an NPM library, and then through this fantastic tool, you can just have a CI/CD that continuously regenerates GraphQL schema definitions. So we came to the final piece of this recipe, right? So the tomatoes are now becoming softer because we put the top on top of your pan. They're getting soft and nice. And now we need to start reducing them, right? So the biggest problem is that we didn't want to build a humongous amount of services in our service mesh, because that one would basically require two different, we had two choices. We actually segregate again per entity the different routes, which is a very painful thing to manage, or we use schema stitching, which is the end of scalability, because you're going to basically recreate a monolith, right? And we said that we want to basically highly distribute it. So we decided to go to use Apollo. Familiar with Apollo? Many people? Great. So Apollo was the library of choice because Federation would allow us to make full use of our service mesh. By the way, I didn't say in the beginning, as a service mesh, we are using Kuma. Is anybody familiar with Kuma? None. Kuma is a great product that you need to check. K-U-M-A is from Kong and is a great service mesh. I highly recommend you to try it. But let's go back for a second because we need to finish to cook our tomato sauce. Apollo Federation. Anybody familiar with the concept of federation? So what it does basically, what Federation does is says, define all the schemas, right? Your user schema and your product schema. And like we said before, they're automatically generated by our models. And what basically happens is that through basically composition through this other component called the gateway, all these different services, they register into the gateway. And the Apollo gateway does the aggregation of queries. And you will say, OK, well, interesting. What does it mean? It means that if you want to query, write a query that says, give me all the products, all the users that have reviews, and give me all the products for that reviews. Those three entities can live in three different separated, deployed, one on GCP, one on Azure, one on AWS. And the Apollo gateway will actually do the stitching behind the scene for you. Just always bear in mind that this stitching is purely virtual because we have Elasticsearch behind the scene. The nicest thing of using Apollo is that Fastify already has implementation for Apollo. So if you're looking for speed and to use that pattern of plugins across all your stack, that's a great choice. And well, the pasta is actually done because the last piece of this sauce was your tomato paste, or how we call it in Italian, il concentrato, that gives that density and that great taste. And that was the recipe. So I invite you to cook this recipe at home and share with me if your tomato sauce was good. And like we say in Italian, ciao.